Okay, good afternoon. So we continue the lesson, but before that, let me check the attendance. And it's clear that probably you are not paying that much attention on to Google Classroom because I sent 3 emails to some 3 students. I've made this spelling wrong. So please check it because I need your name there. Okay, so the books are ready, so we will go for this hard copy book here. But unfortunately, I think you need a code from the librarian to be able to borrow it from the library. And I think he told me that you are supposed to sign something.
We've already done it. It just needs to be processed. That's all. That's
okay. But he will not be here. Probably he will be tomorrow. But I did some scanning from the first few pages, and I put it on Google Classroom. Yeah. So if in case you need to read it, because the first part is actually very basic, and I will not have time to go through all those basics. So most of it will be self-study. So I just want to start with some problems. I am counting on your knowledge from your Grundskolan about calculating numbers and adding fractions and things like that. And of course, it doesn't necessarily mean that if you don't know, you shouldn't ask. Please ask me to see how it goes. Because there are many things in these two books involved. So if you want to pay so much attention to these very basics, no, there is only one way. We have to cut the time for the other parts, and then those are hard. Yes. So, any questions? Okay, so let me start to see how your background is a little bit. So I want to write something, and then I give you a little bit of time. I want you to go through it yourself, but the calculator is not allowed. Hopefully, I don't know how much you can calculate without calculator. Yeah, but sometimes the numbers are a little bit big. But anyway, that's also good to practice a little bit, even though you shouldn't be very worried about calculating. Because you know that in the national exam, you have one part that you are not allowed to use any calculators. Of course, the questions are designed reasonable, so it doesn't give you very, very big numbers. From my perspective, these numbers are also not that big. So let us see how it goes, okay? So the first thing that I want to write here, so I will do this example. And then I want you to evaluate each one of these items. Evaluate, yes?
What do you mean by evaluate?
Evaluate means that find the final number. Of course, this is a number that I want you to simplify and give you the final
result. Let's simplify it.
Yes. Or simplify if you want to. So, for example, if I write 13, let me just try to do one of them together. Minus 2 times negative 7. So if I want to answer this, according to the rules, we talked a little bit about this in the previous session. We have two operations involved. In principle, I should have a pair of brackets to prioritize the operations, but we also have a convention. So here I have multiplication and subtraction. But according to that convention, you know the priority without being mentioned. The priority is with the multiplication. So what does it mean? It means that if you want to write this properly, you just copy and paste this part, which you are not supposed to do anything with it right now. And then you multiply 2 by minus 7. It becomes minus 14. And then you write again 13 minus 14 is plus 14, and then it becomes 27. This is one way of doing that. Might be you are also, more comfortable to multiply the negative sign immediately. So that's also possible. So then it becomes 13. You would say that minus 2 times minus 7 is positive 14, and the answer becomes 27. Yes? So I will actually, this session, basic arithmetics, I will continue these kinds of calculations, but I want to pass through it very quickly. Okay, now you understand what I mean, so I will write some items for you, give a little bit of time for you to think about it, and then we solve it together again. Okay, so let me just write some of them for you. I think 5 items would be good. Now, it's extremely important to have a pen and paper in hand. Just by looking at the problems, you will not learn. Of course, you will understand something, but this is not very efficient. And don't use your calculator. I just want to see how can you manage. Even if the numbers are a little bit big, I want you to be able to do it without calculators.
Oh my days. Okay, that's enough.
Do you have pencils?
No, unfortunately. So, and a little bit more interesting question here.
Oh shit. Wait. Aren't you supposed to use different kind of brackets if you
I will talk about that. Okay. Just please, just work on yourself.
I mean, if one of the parentheses is bigger than the other one, then you can figure out.
Yeah, but just for more clarity, that's all I meant. Have you solved them all?
I've solved two. I'm gonna go.
Okay. Please do not distract others. If you already solved the problem, just keep silent. I want to give the opportunity to everyone to think about the problems. But it's extremely important to do it. It's extremely important. Take a pen and paper. By looking at the problem, you will not learn. This is the first step. These small steps are important if you want to learn something. If you listen to me, I have been teaching mathematics nearly 30 years now, so I have some experience. When I tell you that do this, please do that. You will not learn. I am not that type of person come to you and force you to do something. That's up to you. It's extremely important actually because there is only one number correct. And I want to ask your opinion about that. So it's very important to pay attention to all the details so that you can make one answer to this problem at the end. Okay, let us see how is it going. Something that I hear some students ask is about, for example, if I give you 2 times the priority of operations, what you said is completely correct. You said first parenthesis. I think parenthesis is the British word, and Americans say brackets. Okay, so the brackets, okay, and of course this is in English, in American English, this is called the square brackets, and this is called curly brackets. And then this is just brackets in American English. Okay, I'm just using that. So what you said is completely correct. What's your name?
Hussein.
So you told that the priority is with brackets first, and then exponents, or what you say powers, and then multiplication or division. They are the same level, and then later addition or subtraction. Addition and subtraction are the same level. Some of them needs actually convention. So when I say it needs convention, it means that it needs your memory. So you have to somehow memorize that in this case, you are not allowed to do the subtraction first and then multiplication. This needs memory. This is not something that you understand. Okay? That's a convention. But Kuzai was answering your question. What was your name?
My name?
Yes.
Sharia.
Shari. So Kuzai was answering your question about something like this. So let me change all the numbers. 2 3 to the power of 2. So your question was technically,
No.
should I multiply 2 by 3 first and then
No,
raise it to power 2?
Can I reiterate it?
Pardon?
Can I reiterate my question?
Yes.
My question was based on the brackets, because you know, if you have brackets, you're
No,
supposed
this
to
one I
multiply
know, but you told that it becomes -1. Then you ask, should I first multiply -3 by -1?
Yeah,
And then
exactly.
that's the same story.
Sorry.
Okay?
Yes, continue.
Okay, but the point is that here it really doesn't need your memory.
Yeah.
If you think logically, you find the order. First of all, if you use your memory, as Kuzai mentioned, of course you can find it. Which one should I do first? Exponent.
Yeah.
Yes? And then of course this is something good, you can do it, and this is better to learn it fast. But I mean, even if you think a little bit, you understand this should be the case. It's not something that you need to remember. Why? Because if I ask you to multiply two numbers, the first thing that I should give you are the numbers. I should give you two numbers, 3 and 5, then ask you multiply them, then you multiply them, you give me answer 15, for example. Okay? Now, if I give you multiplication, this is my duty to give the numbers to you first, and then you can multiply. Okay, in this case, what are my numbers? Can you read them? One number is 2, the other number is 3 to the 2, not 3. This dot is between two numbers. One number is 2, the other one is 3 to power 2. There is nothing mysterious about 2, but what is the meaning of 3 to power 2? It is
3 into 3, which would be 9.
9. So 3 to power 2 is another name for 9. So in principle, I am asking you to multiply 2 by 9. What I have done, I have already understood myself that I have to raise 3 to power 2 first to understand what the number is, and then I can multiply the numbers. Okay? So don't get worried. So from now on, I don't know. This is the way that you can understand. If it's a little bit hard, my method is to understand first and then do it a little bit of times, and so that you can memorize it and then do it fast. Doing things fast is also important. Yes? So you should do these things automatically if you want to derive, for example, a manual call, and then if every time you want to think, should I change the gear from 2 to 1 or from 2 to 1, this is not enjoying, you are not enjoying driving, yes? So it should come automatically. So this means that it is better to understand the reason and then do it several times and then send it to your memory and use it over and over again. Okay? Otherwise, you will not be able to solve hard problems.
Yeah.
Okay. Okay. So everyone knows that from now on what we are supposed to do. But let us go back here. I want your answer for this one. Okay. You raise your hand. What did one of you? So what is your answer, Tasneem? What is your name, Tasneem?
Yes.
Yeah. Okay. So Tasneem, what's your name?
For number 2, my answer is -41.
-41. Okay, how many of you agree with this? How many of you disagree?
Which one?
This one is the answer to this number -41. Disagree. So what's your number?
I thought it's 19.
Positive 19?
Yeah.
19. Okay, so let us see how it goes. If I want to calculate this, let us analyze this a little bit. So here I have some products involved, and I have one subtraction involved. This is a minus sign. This is not an operation. Do you agree? Because -11 is not subtracting 11 from another number. So that's the sign. It's a negative sign. It's not negative. It's not subtraction. But this one is a subtraction. You can imagine that. These are signs. Okay, if I want to do this, I have this subtraction here, and then I have two multiplications here and there. So this is not something that I understand. There is a convention going on. Which one has the priority? Yes, everyone just say it. The product. The multiplication has the priority. So what you write, I would write -11. If you want, I can keep this -3 here, minus here, and then I start doing this part. Yes? What is the answer to this part? 3 times -15 in your head. What is the answer?
50.
-15. Yeah. -15 times -2? Positive 30, yes? Positive 30 is the answer, but you have also a negative sign. Okay? So probably you made a mistake in one of these signs. You got this one positive. If you got this one positive, then the correct answer becomes 19. I just want you to ask, do you understand why your method is wrong? Sam, what was your mistake? You need to take lessons from that. So the answer is minus 41. Yes? Do you understand your mistake or not?
Yeah, I understand.
Okay. So if you don't understand, that is up to you to ask me. I'm not in your head. So if you don't understand, please ask me. Okay? So the correct answer to this problem is minus 41. Is that understandable? Everyone understands? Any questions? Do you have questions? No? Okay, so let us go to the next problem, and I want to ask your opinion about that. Let me open up a little bit of a space here. Of course, here you need to analyze a little bit more. Let me write this properly here on the board. So 5 minus 5, and then you have 3 minus, you have another 3, 2 minus 3 to power 7, and then to power 2 multiplied by minus 2. So this is what we want to calculate. Yes? So, first of all, I want you to see, I don't know, let me try to tell you how to think about that. For example, if it is a little bit hard, you know this skill I want you to learn. Okay? What is the horrible part here is this part. Yes? Okay? You shouldn't let the problem confuses you. Okay? Confuse you. So what you do, you can take this part in your head. Yes? It is a little bit horrible, I agree, but that is just a number. So what does it mean? If you do not look inside, what do you see? You see 5, this is this 5, minus, you see another 5, and then there is no operation written between them, but you know what does it mean. What does it mean? What's multiplication? So if you want, you put a dot here. And then you have a black box or whatever here. And then you have the product with another number. Then I think it is extremely simple for you to understand. So this is, even though it is written a little bit in a big form, but this is possible for everyone to understand. So I don't consider this part of mathematics hard. Okay? Is that clear? This is a little bit big, but you can analyze it. It is the structure. The structure of this expression is that expression. And do you have any problems? If I give you this 1, 3, I am completely sure that you can solve it if that's a simple number. So the whole thing reduces to a new problem. This is skill you have to develop. So this is a problem. Now I realize the main problem is this empty space here. Yes? So if I can answer that question mark, because I have already done my homework properly, then I am relieved here. Because I know how to do with this one. Is that understandable? Yes or no?
Yes.
These things that I am talking to you, this will repeat itself. It doesn't matter, are you studying elementary mathematics or are you studying the most advanced mathematics? This is the way that you have to start to think. Reduce a complicated problem. I will come back to you, okay? Reduce the complicated problem to smaller, manageable pieces. Yes? So the first thing that you do, if it is not hard, so you solve it. If it is hard, you have to improve this skill to break down the problem into simple pieces. And then manage to solve each simple piece and then combine them back again to solve the original problem. Okay? This strategy is always working. It doesn't matter. Even if you are writing a program code, computer code or whatever, you have to be able to learn this. In chemistry, biology, and everything. Because the universe is so complicated, we cannot just tackle the problem and understand everything. We have to model something out of it and try to study the model. Okay, so now this means that when you give me this problem based on experience and attention, constant attention. I have paid constant attention, and then finally I learned to be able to break down the problem into simpler pieces. Okay? Okay, now this means that for the time being, try to improve this. Forget about the rest and try to just focus on your question mark. After that question mark is answered, you can come back and glue it to the main problem. Okay? So this means that I want you to learn these things. It takes time in the beginning, but this is the only way that you can do mathematics. Okay? So my question is that I go in a scratch paper or wherever you want to and rewrite it again. Don't be lazy. You should enjoy writing so much. Yes? And then to the power of 2. Yes? Okay. Now you see I started with this problem and I realized the only problem that I have is this problem. If this problem is simple, just do it. If that problem is hard, you have to learn to break it down. Yes?
When we're dealing with, let's say here's to the power of 7 to the power of 2.
Yes?
In this case, we can multiply 7 with 2 and then we would have to the power of 14.
No.
No?
That's what I'm saying.
Would it be added?
You don't let me just finish, okay? Okay, so now we want you to understand, I want you to understand this. Okay, which part? I want you to do this trick once more. Can you do it for me? If you can do it quickly, do it. Be my guest. If not, it doesn't mean that you should solve it wrong. You should be able to model out the way that I did it here. Which part of this problem is hard? Yeah, no. Yes, you. What's your name? Abdurrahman, okay.
After I get -1, what do I do?
What?
After I get -1.
No, I mean that if I want to put a question mark somewhere on this problem, where do you put the question mark?
2 minus 3 to the power of 7.
Pardon?
2 minus 3 to the power of 7.
Okay, this is correct, but I don't want to jump immediately to that part. Because what are you facing? You want to raise a number to power 2. Don't let this big form of the number distract you. If I ask you what is this, you will tell me this is the square of a number. Do you agree? If you read it, this is a square of a number. This is power 2 of which number? Of this number. Yes? So you see, I reduce the problem to this question mark. For answering that question mark, I reduce the problem to this question mark. Because I love writing mathematics, I rewrite it again. Yes? So now, my problem is to solve this problem. Let me ask you one question. Is this problem simpler or the original problem? This problem is simpler. So it means that I managed to reduce a harder problem to simpler problems, with the hope that I finally be able to solve that. Okay? Now, if you want to solve this, I don't think it is a hard problem now for you, because you know the operations. I have a pair of brackets, I have a power, I have a multiplication, I have a subtraction. Of course, if this is still hard, you can reduce it again, but I don't think it is hard, because now it's exactly according to the rule that I'm following. The priority is which one of these operations? Just tell me.
Exponent.
Exponent. So no, just listen to him. What was that? Parentheses. Yes. So you have to do this. So it means that I take my pen. When I want, by the way, writing properly is also very important. When I want to do something here, I am not allowed to be lazy and do not write these. You have to copy and paste everything up to that point. And then 2 minus 3 is how much?
Minus 1.
What?
Minus 1.
Minus 1. And then you have 7.
Minus 7.
Yes? And then you continue.
It's multiplied.
Okay? Now again, you have a pair of brackets, but that is not important because that is a subtract, that's a sign, and you are supposed to raise it to power 7. So minus 1 to power 7, what does this mean? It means minus 1 multiplied by minus 1.
Minus 1 multiplied by itself.
Minus 1 minus 1. Don't
Finally
be,
comes
yeah,
to
1, 2,
minus
3, 4,
-1.
5.
So the answer is
One.
-1.
Oh yes, exactly. So everyone knows that if I multiply minus 1 odd number of times, the answer becomes minus 1. So this means that I go one step further. It becomes 3 minus 3 minus 1 to power, oh sorry, minus 1. Okay, that's correct. And then I multiply them. What's the answer? 3 plus 3, yes? And the answer becomes? No, 6.
Oh, yeah, 6.
You're not multiplying here. Okay, so be careful. What I did, I calculated this question mark. But what is the blue question mark? The whole expression. So the blue question mark is how much? 6 to power? 6 to power 2, which is 36. Yes or no? Okay, now everything is ready, so you can write this as 5 minus 5. Instead of this guy, I just write 36. Instead of this one, I write minus 2. Okay, but at least, even if you are not very fan of calculating numbers, you can take your calculator and calculate it. But here I don't think it is hard. For example, if you want to multiply this, can you tell me immediately what the answer is? What? Yes? You?
What did you ask me?
Yes?
No, I had a question.
I will come back to you later. Okay, what is the answer to this?
180.
This one, the whole expression.
Oh, the whole.
360.
360. How did you calculate it?
36 times -2. And
Yeah.
then that was -72.
Definitely that is correct. But it is not efficient for our brains. If I were you, I multiply 5 by 2,
36.
which is 10, and 10 multiplied by 360 is easier for my brain. Of course, your method is 100% correct. Yes? But try to understand which one is more efficient. So for me, I want to multiply these three numbers. I know that order doesn't matter. So I myself multiply minus 2 by minus 5 by minus 2 in my head, positive 10. Positive 10 times 36 is 300, positive 360. And then I have a 5 here. So the answer becomes the number of days in a year. Yes? So the answer is 365.
Because -5 is -2 is 10.
Is that clear?
This turned into
Okay, now I go back to your question.
36 into 10.
Pardon?
Why did you make it?
360 plus 5.
The simpler is always better.
Isn't it?
No, because you could have solved it from the first.
No, I told you. If you have already trained your brain, you really don't need to explain so long. You can just go directly and solve the problem. But be careful. This is something that I want. It doesn't matter how brilliant you are. Mathematics is harder than you imagine, because there are many problems. For example, this last Fermat theorem was actually a very problem, easy to state, even you understood, but it took 300 years for mathematicians to be able to solve it eventually. So I mean that if you, all of those mathematicians know these tricks very, very well. It's even better than every one of us here. But the point is that mathematics is still very hard. So if you don't respect these methods, you will not be able to solve hard problems. Of course, you can solve level 1 problems. Even level 3 problems here are not a hard problem. Are not hard problems. You have to learn, yes, you have to learn to solve harder problems. Okay, this is what I'm saying. I don't want to look at these problems. I want you to talk to yourself. Try to repeat what I gave you as a recipe. To repeat this over and over again. And then finally you will learn that, and then you will apply it for all the problems that you are using. It doesn't matter which subject you are studying. Okay, so I don't think this will actually bother you that much. So, but I want you to final correct answer. Okay, for this one and for that one. I'll wait a little bit more again. Okay, just I want you to also, when you got your laptop, so let me just show you this app here. This is GeoGebra. It will be extremely useful for our courses in mathematics, in any course that we will be studying from today until the end of high school. Okay, so I want you to download it later. It's completely for free. GeoGebra Classic. I downloaded version 6. There are two versions, Classics 5, Classics 6. This is the Classics 6. And then when you open it, you see something like this. You can do a lot of things. And then you can see that I have something called CAS. So I can do some calculations using this view. This is the algebra view. So I just click on it. And let us try to learn if we did it right. For example, let us just punch this in to see how it goes. Okay, so what was the answer? So I just write 5. By the way, there is a keyboard here. Probably you have access to a lot of things if you don't have it on your keyboard, or if it is in Swedish. So you can also download the application in any language that you want, but I prefer to download it in English. So it is 5. So let me write this. A good point is that it does not write a computer code. It writes like a human handwriting. So I would write, I want to punch the same problem we just solved and got 365. So it is very, very important that you learn this application, how to work with this application efficiently. Okay. So then I put 3 there, minus 3. Another pair of brackets. It always opens and closes the bracket when you press the button, okay? And then I have 2 minus 3 here, and then you see I have to go and raise it to power. In English keyboard that I am using, Shift-She is the exponent, but if you do not, I think in Swedish keyboard you know what to do, I don't know. But this, you can just use this button here, you see? And then it goes there. And then what was the power? It was power 7. And then outside that, so I come out, and then again another power to power 2. Do you think my typing is right?
Yes.
And one of you asked why I am not using square brackets. This is not very standard. This is why I prefer to put the brackets outside a little bit bigger. And if I have more pairs of brackets, I made them bigger and bigger. Yes? Okay, and then you come down. Everything is finished and you press enter. This is wrong. So what we got wrong, you have to be careful. Okay. This is not finished. I forgot to punch this minus 2 in. Yes? So I put minus 2 there. Of course, this is a very good thing to understand what is going on. I think the product symbol is here. You see here. So I press this one. And then I put brackets minus 2. And then I put enter. So it's plus 365. So this is the number that we got. And of course, if you can make it bigger, so yeah. So everything is going. I really want you, when you got your laptop, immediately download this app and try to use it creatively. Don't wait for me to give some advice to you. You can always understand how to do it. Okay, now that we know this, we go back and I want to... do you have any answer for the next part?
Number 5?
Yes, number 5. Number 4.
Okay, number 4 is 192.
Okay, let me just check your answer. What?
192 for number 4.
Okay, 192. Let me check it using GeoGebra. So it is minus 3, and then I put this product here, and then I have minus 4 to power 2. And then what I have minus another pair minus 5, and then I have dot, and then I have minus 2 to power 3, and then I have another dot minus 6. So this, what did you say? 192, that's correct. Yes? How many of you got this answer right? So that's good. Okay. Yes? This is the pattern, but you need to do something, you need to find one answer. Okay, one thing that I want to mention is even if you have this software, so let me switch to the camera mode.
This is the pattern for number 5.
So, even if you have access to GeoGebra, as we have now, solving this problem using GeoGebra is a little bit more different. Either you have to be so patient, start to punch all these numbers starting from 135 up to 67, of course in that case it will work. But then immediately realize that if I am a crazy teacher and I give you until 1000, what do you want to do? Even typing it in the computer is not that effective. Of course, there is some methods that you can use other instructions in GeoGebra to be able to solve this more or less very quickly.
Which term do we need to find?
Pardon?
Which term do we need to find there?
No, there is no term to find.
No. Like
This is
after
a
we find
sum or difference. I want you to give me one number at the end of this.
Oh, okay. All right.
Yes, that's what I'm asking. Okay. What I'm saying is that you really need to understand, because even if you have the best software available, you need to know how to work with it. And then, for example, we can come back to this. Can you find, that could be a good project for you to learn GeoGebra. Can you find, by just going up and down in GeoGebra, reading a little bit, Googling around, can you find a way that I can use GeoGebra to find this without typing everything? This will teach you a lot of things, of course. Okay? But for the time being, I want to ask your opinion about this. Forget about GeoGebra momentarily, and I want you to tell me, how do you think about the problem? And if you have already solved that, guide me to solve them and explain to your friends. Yes? Yeah, it was your turn, and if you cannot, you can go.
Number 5, after 10, there are down some dots.
Okay, I told you this, so let me just ask once more. Everyone, do you understand what is the meaning of these dots?
Yes.
What does it mean? It means that it's a pattern going on, and I am telling you continue the pattern. For example, if I write 2 plus 5 plus 8 plus 11, and then I write some dots, I hope that you can guess what is coming next. Yes? Of course, the pattern here is a little bit more complicated because it is addition and subtraction simultaneously involved. Yes? So that's what I'm saying. You need to tell me how to do that, or how do you think about this problem. Yes?
I'm thinking of wild guess.
That's very good. What you said is very common in the world of mathematics. You do some wild guess. The better is an educated guess, not wild guess. But little by little, we will actually come to a solution, hopefully. Yes.
Is the answer 84?
I don't. Okay, I can probably have the final answer. What did you say?
Is the answer 84?
Part. No.
Okay.
Minus 100.
But I think you have done a very minor mistake. Let me see. No, the book answered something different. I don't know if it is written correct or not. We can check it again. But any other answers for this problem? I think you understood what to do, because when I see the numbers, I realize that you have made a small mistake if I am right. Any other numbers for this? Yes?
Minus 102.
Correct.
What did you say?
Minus 102.
Jesus.
Anyone else? Minus 102? Please raise your hands.
I got the minus.
Anyone else got minus 102 for this problem? No. So okay, that's good. But good.
Minus.
Yeah, I'm happy that some of you actually could do that. Then of course we can solve the harder problems. Okay. So if I want to solve this problem, what I do, I don't know how you thought about the problem. You can solve this problem in not a lot of ways, but probably different ways. Okay. The one that I think is more efficient, can you talk about that for me? What was your way of thinking?
So I realized two things. The first thing I saw, when there's a plus in front of the number, that corresponds to the same number in the pattern. So when it's plus 7, it's the 7th number. When it's plus 5, it's the 5th number.
Okay.
Then when I went to plus 67, that's the 67th number in the pattern. So we know minus 70 is the 68th.
Yes.
So then the second thing I realized is that whenever we go up 2 numbers, the answer is minus 3, and then it's going down by minus 3 each time. So at the second number, it's minus 3.
Mm-hmm.
The fourth number, it's minus 6. Then minus 9, then minus 12. So if you go all the way to the 68th number, you do 68 divided by 2
Mm-hmm.
times minus 3, and
Yeah.
you get minus 102.
Okay. That's very good. Any other method? So what was your method?
I did 70 minus 4, and then divided that by 2, and then I got 34, and then I did 34 times minus 3.
But that's very complicated for me to understand. How did you understand that this is working? May you repeat it again?
70.
So you took 7 minus 70.
No, 70.
Se-
That was
70
minus 4 in brackets.
minus 4 in brackets.
And then I did that divided by 2.
And this one divided by 2?
Yeah.
Okay.
And then I got 34.
This you will get 34. I agree with...
No, the 66.
No. So this becomes 66 divided by 2, 33.
Yeah, oh no, that's the wrong. No.
What? It's not working.
No.
So that even it was... So I don't understand. Could you solve the problem eventually or not?
Yes, that's why I did the numbers.
You made a mistake or not?
You made the mistake in the calculation.
Okay. But then it was very strange for me. How did you know that this method is going to work? I don't understand. How did you choose this and then minus 4 and then divide by 2? I mean, your method is probably complicated. If it is going to work, it is not a coincidence, I would say, but you should defend your method.
It's minus 2, not minus 4. Because it's...
Here,
Yes.
and then it becomes 34.
Yeah. And then it's 34.
Okay, and then
Times
what?
minus 3.
34 times minus 3. It is completely the correct answer. But I don't understand your method.
What the hell?
Because it goes up with 2 with every, like the second number. So it's 4, 6, 10. Do you get what I mean by that?
No.
Like, so it's,
She's saying that the negative numbers always go up by 2.
Okay.
yeah, and it's 70 of those, but like we don't start from 2, we start from 4. So now it's the rest.
No, all benefits.
Okay, I mean, I would say that this is a very genius method because I don't understand it, and I don't want to say that this is a coincidence because you got the correct number. Might be there is an, but then how did you realize you should multiply by minus 3?
Because
YOLO.
it's like
Aha! Now I understand.
minus 3 plus minus 3. So
Exactly.
and it's 30.
Now I understand. Actually, this is my method, but you express it in a way that I was quite myself confused. What I was trying to say, I was thinking in this way. Instead of looking these numbers separately, I was realized that let us take them 2 by 2. Everyone knows what is 1 minus 4. Minus 3. And then what is 3 minus 6 again? Minus 3. Yes? And then what is 5 minus 8? Minus 3. And that is 7 minus 10. It's minus 3, and it will continue minus. Yes? And then what she is telling us there are 34 minus 3's involved. Yes? It's a very good method. That is the method that I was thinking, but I didn't understand how did you brought this number. I was trying to ask you how many minus 3's you see in this list. Yeah, please keep quiet. Hello, hello.
Quiet, please.
Yeah. Now the question is this. This is my method. I wanted to explain this method to you, but of course I didn't thought about this number 34. I was trying to find it later. Now my question for you is that, do you understand this method? So you, in principle, in your head, you can put an invisible pair of brackets around them. It will not change the problem. Yes? And then you see each term is minus 3. So the only thing is that if there are 2 minus 3's in this list, the answer is 2 times minus 3. If there are 3 minus 3's in this list, the answer is 3 times minus 3. So the only question is that how many minus 3's I see in this list. Yes? And then she actually told us we see 34. Now I want you to convince me and yourself that she is right. There are indeed 34 minus 3's in this list. Why is that? So you did it magically. You take 70 minus 2 divided by 2 and it becomes the right number. But can you defend that, or someone else? Can you tell me why? How can you understand that there are 34 minus 3's in the whole list? If you can do that, then we are done. Yes?
You can do it individually.
Yes? How?
And then just
I don't get it.
Okay, how many of them are there?
the answer is 3, 2, and if you divide it by 34, then you get -3.
No, but I think you also partially answered that. So you said that 1, 3, 5, these are what? How many odd numbers? If we can count them, we are done. If I ask you, you start from 1, 3, 5, 7, up to 67, how many odd numbers you have in your list? This is why you have divided by 2.
Can I explain why I did minus 2?
Yes?
So if it would have started from that, what's it called, the positive number,
Yeah.
would be 2,
Mhm.
it would be 2, 4, 6, 8, 10,
Mhm.
then it would be 5 for every 10. So that's
Exactly.
then I would have done it just 70 divided by 2.
2.
If
Yes.
it would have started with 2.
Yes. Now it has started from 2, so you have exactly. That's correct. So anyway, you should ask yourself, I have one, it should be simple for you, by the way, it's not a hard problem. I have a list of odd numbers, 1, 3, 5, 7, and it continues until 67. If I ask you how many odd numbers you see in this list, it takes a little bit of time, but this is not a complicated problem at your level. Yes, you should be able to answer this. How many of them are there? 67 minus the first one, but it goes 2 at each time. So this is why you divide by 2. This is also another way.
Way.
Yes. You also describe the same thing.
So smart.
Yes, but in a little bit different way. But I was thinking that why should I bother? So you talked about even numbers. Exactly. It was easier for you because what she did, she was counting the even numbers. Yes, she counted the number of even numbers in this list.
You did it with the odd ones.
I did the odd ones because the odd ones are easier. Odd ones start automatically from 1. I don't need to be so creative as you was to be able to subtract 2. You know, that's what I'm saying. But that's okay. So this is a good problem. I mean,
Wait, I'm sorry, I just don't get it. How was it -1 at the end? Is it?
If that's -1, then that shouldn't be 34. 68 divided by 2 is 34.
oh, sorry, plus 1. No. So let me, yes. No, then last, okay, by the way, this is a very good thing that I want to teach you right now. If I ask you how many numbers are there from 1 to 10, how many numbers are there? 10, not 10 minus 1. Okay? 10 minus 1 is 9. Because sometimes people say there are 10 minus 1 numbers. Okay? So the correct thing is that this we will study. This kind of sequences are called arithmetic progressions. In arithmetic progressions, if you want to see how many terms are there, you take the last one, subtract it from the first one. So in this case, I write 70 minus 4. And it goes 2 units at a time, so I divide by 2, but it is extremely important to add 1 at the end.
Why?
Okay?
Why?
I can prove it later for you, but for the time being, just I can write it for you. Why?
So it's the first.
Because 4, this one can be written as 2 times 2. This number can be written as 2 times 3. This number can, this is the way that she explained. 2 times 4, and then I can go to 2 times 35. Yes? And then you see 2, 3, 4, up to 35. How many numbers are there? 30, no, it starts from 2. 34. Yes? You can understand this in that respect. Okay, let me change the problem a little bit so that I want to see how you can solve the problem. Yes? Louder.
Can you please explain the 7 plus 1 divided by 2?
Okay, so let me do it a different way. As I explained here. If I ask you 4, 6, 8, these are even numbers. Do you agree with me if I continue this list like this, eventually I will reach to 70.
Yes.
And then I want to see how many numbers are in this list.
Yes.
Instead of 4, in my head I write 2 times 2. Instead of 6, I write 2 times 3. Instead of 8, I write 2 times 4, and if I continue this pattern, the last number becomes 2 times 35. Now look, this 2 on the left-hand side is common to all of them. But in the first one, I have 2. The next one, it becomes 3. The next one becomes 4. The next one becomes 5. And eventually, the final one becomes 35. So I have a list of numbers 2, 3, 4, 5, up to 35. And I want to ask how many numbers are in this list. If I have started from 1 up to 35, it would have been 35 numbers. But now I have started from 2 up to 35. So there are 34 numbers.
Okay, I understand. Thank you.
Yes, you're welcome. But then the point is that this division by 2, she managed to convince herself that this division by 2 is okay. This division by 2 that she is using here, I have used as a multiplication of 2 here. It doesn't matter. But we will later we will study these sequences. These are arithmetic progressions, and we will study them. Okay. Let me ask you one question. What time is it? We have a little bit of time. I hope that you are not.
Can you just give us write an example on the board that we all can work together to solve?
Yes, I will do that.
Can I write a solution on the board?
But for
Can I
this
write
one,
mine? Yes, for this one.
yes, come in. But you will be recorded, and you will be on YouTube. Okay? That's up to you.
Yeah, I'm just gonna go. Yeah, but show your stick first.
So please bring the upper board down so that you can write there.
Let's see how
Sure, don't make a mistake.
Oh, what the hell? So that is. N is turn, right?
No, he is using the arithmetic progression formulas that we will study later.
So we don't even study them. Oh, you're 18. You completed all this. How do you even supposed to?
He's already finished talking.
He's 18, bro. He can buy us all drinks.
I'm not going to do that.
Oh shit, my bad.
So what is minus 3 then? I don't understand that.
That's the difference. Number of turns being
No, the formula that you have written is correct,
Yes.
but minus 3 is wrong.
Oh yeah. What was I supposed to do here then? I forgot.
Okay, if you don't mind, let us not get involved with this. Yes?
Yes,
Because first of all, it means that what you have done, the formula you have written is correct, but n is the number of terms.
Oh,
The common difference is d.
okay. Yeah.
Yes?
The number of turns is
No, but
58.
But forget about that. Yes. You are calculating the sum.
Were we supposed to calculate the sum at the end?
We are supposed to calculate the sum here.
Oh,
That
just
is not
the
that
last
sum.
two. Oh, okay,
No,
just last two.
we are supposed to
Oh.
calculate this sum.
I thought we were supposed to calculate the final sum of all numbers.
This is the final
But
sum.
if you see there, okay,
Yes. The answer to this turns out to be minus 102 in total. Yes. Okay. Okay, now let me ask you, I don't know, can you calculate these things, by the way? Listen to me, please. Can you calculate these things more or less easily? Are you comfortable with these calculations?
YouTube quiz.
Okay, so I want you to work this out. Write this without decimal points. Decimal points are good when you want to feel the number. But in higher mathematics, we always stick to fractions. And there is a good reason for that. So please listen to me. I want to have your attention. 1 over 3. If in exam you write 0.3, I will actually cross it over. 0.3 is not 1/3. 0.3 is an approximation to 1 over 3. 0.33, if you write this equal 0.33, no, it's wrong. In mathematics, when you say equality, it means that it is 100% precise. In physics, you can say that, okay, with 2 decimal points, I can approximate 1 over 3 with this number. So if the answer to a mathematical problem is 1/3, and you write this number for me, you'll lose the question. Yes?
If you write 1/3 equals 0.33 with the line over it.
Yeah, that I will accept that. But then I don't like it again. Yes? Yeah, because I want you to learn work with fractions and be comfortable with working fractions. In that case, if you write 0.3 with this bar, then if you ask me true or false, that's true. And it means that, but the point is that you don't have national exam, but in the national exam, if the answer to the problem, short questions, is this one and you write this one according to Bedomning, I should give you 0 again. So be careful. By the way, that's not bad, because you can talk about this to primary school students, but you probably cannot talk about this about primary school students. So I mean that even our brain is more used to this than this. That's reasonable, yes? Okay, so what I want you to do, I give you some time to work this out, because I want to see that everyone knows how to do these simple calculations. Then of course we can do a little bit nicer problems. Yeah, okay, so let us just do this one and then we continue tomorrow. So here, first of all, what I see, I have to get rid of this minus sign here. I hope that you know there is no difference between this symbol and this symbol
It's minus 60. Look.
and this symbol.
5 2 is 10. What is that? 10.
So be careful about this point.
30 times minus 2 is minus 60.
Okay?
So you have minus
There are no differences between these notations. So this means that instead of having minus sign here, I can bring a minus sign here, but there is another minus sign here, so it becomes positive.
Oh, there was a minus 20.
It's minus 20. Yes? So what I do first, I write minus 7 over 15, plus 3 over 10, plus 9 over 20. Yes? And now, you don't have the common denominators. You have to make the denominators the same by rescale them properly. Okay? One thing that I have seen students do is to multiply these numbers. It is correct, it will work, but it is not efficient at all. So if you just multiply them, it works, but it is really, really bad if you get used to multiplying them all the time. It doesn't matter that much with numbers because you have calculator in front of you, but when you go to the second year, you want to do this with algebraic expressions. And if you get used to multiplying them, it's not possible to solve those problems.
So you change the positive plus minus.
This minus, according to this rule, will go here, and when I have a minus here, another minus here, it becomes positive. Yes? Something like that. I bring it up, but there is another minus sign up, so this becomes minus, minus becomes positive. No, but you have to be careful. This is the rule. I can bring the minus sign up, but not necessarily. I cannot get rid of it. The reason that I was able to get rid of it because there was another minus sign there. Hello, don't talk please. I cannot hear. Yes.
If the 9 is negative, write that down.
Okay. So what is your question?
Let's say that number 9 is negative.
And then what is here?
You can't do 2 decimals.
Next minus.
Positive.
I'm doing it like
In that case, it becomes negative.
belongs to the whole one. So you can either put this one negative.
Because this negative sign goes here, and this becomes positive negative 920. So this positive times negative becomes negative.
If it is multiply.
No, this doesn't mean multiply. What do you mean
No,
multiply?
if you put times and then negative 9 over 20.
Then it becomes times negative 9 over 20. Yes? Okay, so if you want to solve this problem, you need to find the most efficient common denominator. Common denominator is a number that is divisible by all of them simultaneously, but the smallest possible one that you can think. There is a systematic method to find that if the numbers are so big. I will discuss about that later. But this is not so big, you can do it in your head. Can you tell me a number which is simultaneously divisible by these three, and there are no smaller number than that? No, you are thinking the other way around.
60.
Yes, 60. So the number is 60. Can I find smaller than 60?
No.
Is 30 suitable?
No.
No, 30 is good for this one, is good for this one, but it's not good for this one. So the smallest one that we can get is 60. Okay? So what I do, I will write 60 here, 60 here, and 60 here. Okay? And then I ask myself, 15 is rescaled to 60 by being multiplied by 4. I have to do the same thing in the numerator. So yeah, minus sign is here. This becomes 28. And then I have a plus sign, 10 is rescaled to 60 by being multiplied to 6. So I do the same thing here. It becomes 18. And then by 3, it becomes 20. Okay? And then what will be the answer? I have to write the common denominator. You can do it in your head. You have minus 28 plus 18 is how much?
46.
No. Minus 28 plus 18. Negative 10. And then you have 37.
17.
This is 37, yes? So you see, you can do like this. This is minus 28. This is 27. They are very close to each other. 27 minus... I made a mistake.
Yeah, you added.
Yes, I added. 27 minus 20. This is minus 1. This is 17. Yes? So the answer is 17 over 60.
I got the answer with minus.
So these kind of calculations, I will actually, tomorrow I will continue a little bit of that and then we'll switch the topic. But this is something that you need to know. Any questions?
Sir.
Yes?
Where does the 60? Yeah.
Pardon?
Where does the 60? Yeah.
So here I did some guesswork. Okay, I mean I was looking for a number with two properties. First of all, I want a number which is divisible by these three. Okay? On the other hand, I want to keep it as small as possible. You cannot find a number smaller than 60 with these two properties. But you might ask yourself, if the numbers are so big that I cannot calculate it in my head, is there any method to do that? I would say yes.
Makes sense, yeah.
Pardon?
15 times 2, 30. 30 times 2, 60.
Yes. But if the numbers are not so friendly, even I cannot calculate it in my head, but there is a method that I will teach you later how to find them if the numbers are big. But is the problem solved?
Yeah.
Okay, no questions?
No question.
Okay, let me just stop the recording. Okay, thank you very much. See you tomorrow.